Hey guys, Chili here. Welcome back to Project Twin. Today we are going to implement damage and destruction of the poos, and we are going to implement some sound effects and some visual effects for that. So no matter how many times we hit these goddamn poos, little fuckers don't die. So let's change that. All poos must die. So I had a sound effect for hitting the poo, or maybe for killing the poo. I can't remember. But we change activate effect to apply damage, and we give it a damage parameter, and we give the poo some hit points, and we subtract damage from hit points when we apply damage. And we also have a function here to check if a poo is dead, which is just, you know, if the hit points are less than or equal to 0. Now, in game, what did we change? We added the sound here, and so when we apply damage, we give it just some, I just hard-coded some bullshit damage into here. Just for testing purposes, that'll be fixed up a little later. And then at the end here, we clear all the dead poos. This is a very common pattern, by the way. You might say, why don't you destroy all the poos in this loop? But that'll mess up some of the other things we're looping through. It's better to do all of your calculations, and then when all the dust is settled, remove all of the dead bodies. And this is the way you have to do it in things like Box 2D, and this is also the way things are often done in stuff like Unreal Engine 2. In fact, in Unreal Engine 2, it is very common to just spawn all of your actors at the beginning of a level, and they all just stay spawned. Even when they're dead, you just basically hide them and remove them from physics, but you don't actually destroy them until the end when you're going to load or whatever. Now, the next thing I'm going to do here is I'm adding a background, because, you know, just plain gray is kind of boring, so I added a bitmap for floor tile, and added some stuff here. Let's see what I added. In Vec2, I include Chili Math. That's about it. So what is in Chili Math? Chili Math just gives us C Math. It gives us some, you know, pi constants, and it gives us a function here, int or div int ceil. Now the way this works is, let's say you divide 6 divided by 3. 6 divided by 3 is 2. But if you divide 7 divided by 3, 7 divided by 3 is 2, remainder 1, and so with the ceiling we would round up to 3. So if there is any remainder, you round up, and that can be achieved with this calculation here. And in rectangle, we add some functions to get top left point and the bottom right point of the rectangle as a vector. Can be useful. And let's take a look at background.h, because this is what is going to store and draw our background of tiles. So we've got a surface for the floor, we've got an origin for the background, width and the height. And it's just going to take the floor, and it is going to copy that tile in a grid based on the grid width and the grid height. And the grid width and the grid height are just calculated based on the width and the height of the screen. So this is just determining the minimum amount of tiles across and tiles down we need to cover the area specified by this rectangle that was passed in, which is going to be the screen rect. And we do that by using the floor, the surface here, the dimensions of the surface, to figure out how big a single tile will be. And then for draw, we do our standard grid drawing bullshit. This would be pretty straightforward if you've done SNEC before, only instead of just drawing a solid rectangle, we're going to be drawing a surface here, draw sprite. And with the copy effect, you don't need any chroma for background tile. In game.h, we include the background. In game.cpp, we initialize the background, a little bit of comment in there, and down here we draw the background. It's the first thing we draw because we want to draw all of our stuff over top of the background. And if we run that, we can see now we've got a little bit of a tiled background here, and we can also see that we can now destroy our poos with lovely sound effects. Now, just having the poos disappear on death is kind of boring. So what I've done is I started off by creating a little effect here called the dissolve effect, and I tested it, and the dissolve effect does a couple of things. I call it dissolve half tint. Alright, dissolve half tint is kind of a complicated effect, so let me go over it quickly here. There's 3 things going on. First of all, it's chroma, so we're going to do a chroma test. We're only going to draw pixels if they pass the test. Now, Second thing here is it's tinting. So what that's doing is it is blending all of the pixels of the source with some solid color. And the way you blend with a solid color is you divide the color pixel of the source, and you divide this one by 2, and then you add them together. It's a simple average. And the way we're going to do that is, instead of dividing each individual channel by 2 by unpacking them, we're going to shift the whole thing right by 2. And that divides the entire number by 2 of the packed channels. And that's almost good, except that now you're going to have a bleed from one channel into the other, because the low bit of one channel will be shifted into the high bit of the neighbor channel. So in order to remove that bleeding, we mask with this value here, and that will just mask out all the high bits. Because if you shift right by 1, the high bits should all be 0 anyways, so it doesn't matter. Just clear all the high bits. And we pre-calculate that for the tint value, because that doesn't change over the entire sprite. And then here, we do the same for every pixel, and we add that to the tinted one. And that gives us the proper result. So that gives us our blended pixel. Now, the dissolve thing, basically all it does is it only draws a certain percent of the scan lines. And it does that based on basically modular arithmetic. So it repeats every 8 scan line the same pattern, and within that 8 scan line pattern it will only draw, 50% of them or 25% of them. You'll see when we actually get to it. So this here, I implement that, I test it. Then I implement it for the poo. So what I'm doing here is I am giving the poo an effect state. It's got 3 states: normal, hit, that's when it flashes white, and dying is when we do the dissolve. And what do we got here? So we give it an effect state enumeration. It starts off normal. Is ready for removal. This is just telling us whether we can remove it, because now when the poo dies, it's not going to immediately disappear. It is going to play a dying animation. So we want this to signal, let's keep track of when the poo is actually ready to be removed. And then we've got some constants here to determine what is this? How long it should dissolve, basically how long the death animation plays, and how long the hit animation should flash. So we got a whole bunch of bullshit there. And how do we do this? Well, let's just get rid of this here because it's not that useful. So when we're going to draw the poo, we switch to effect state. If it's hit, we draw it with the flash. If it's dying, we draw it with the 1 minus the effect time divide by dissolve duration, right? So effect time is how long the effect has been playing, the current effect, and dissolve duration is how long the dissolve duration lasts. So if we divide this, we get a percentage, and we want to subtract that. So the larger this percentage, the less we want to draw of the sprite, because it's going to be dissolving. So we do 1 minus the percentage, and that will draw it in the dying animation. And then for normal, we just, we do the normal chroma drawing. And down here, what is ready for removal replaced is dead. And where is ready for removal being, so here in update, we are also updating the drawing state of the poo. So first off, we're only going to update its position if it's not dead, because dead poos don't move. So we want to make sure that we're not moving our poos still even when they're dead. Next thing we want to do here is effect state. If it's hit, like if it's in the flash duration, we let it flash. Once it exceeds the flash time, now we got to check to see if it's dead. If it is dead, then we want to transition to the dying, and we want to reset the effect time. But if it's not dead, we put it back into its normal effect state. And if it is dying during update, then we want to check to see if the effect time has elapsed. And if it has elapsed, then we flag it ready for removal. So a lot of complications here. This is a basic state machine is what this is. And it's a little different approach than what I did for the dude. I didn't put it in a separate component class inside of the poo. Here I just put it all the same inside the poo. I'm not sure which I like more. I probably like something completely different more that I will be doing in the future. But this works. So before I was playing the death sound when I was removing the poo, but that's after it dies, right? That's after the death animation plays. I want to remove it as soon as the death animation starts. So here I check to see if poo is dead inside here. If so, I play the death. If not, I play the normal hit sound. And I changed the death sound as well, made it a little better, not just the made a little better sound for that. And here what I do, I tweak the dissolve effect. So I made it dissolve every 4th line instead of every 8th line. And in poo, what do? I make it dissolve a little faster here. So the dissolve duration is now 0.6 seconds. And if you run this, now you can see poos are dissolving. I don't know if you can hear the death sound. Let me just shut up for a second. So there, I hope you see what I mean by the dissolve effect, where it draws less scan lines as the effect progresses. But that's gonna about do it for today. Thanks for watching. Hope you enjoyed the video. If you did, please click the like button, it helps a lot. And I will see you soon with some more Project Twin.